Hello viewers, welcome to EF once again. And today I would like to discuss about what is the formal definition of transition relation notation. After that, what is the non-deterministic Turing machine formal definition, and at the end I will discuss what is the deterministic Turing machine and non-deterministic Turing machine. This is the 8th video of complexity theory of IT security power. Now let's see the formal definition of transition relation. Here we have a Turing machine TM which will accept M by a given Turing machine defined in a way where we have W, a particular input which belongs to sigma star, such that the initial state we have W input, and then the deterministic Turing machine, after starting many steps, we will accept this QS state, where I have before the QS state I have alpha 1, and after QS state I have alpha 2 many string, where alpha 1 and alpha 2 which belongs to working alphabet. Now here I use this QS yes symbol, means the accepted final step, by QJ. It is also symbolized by QY, or sometimes some other symbols like double circle and so on. So let's see the next question. The formal definition of non-deterministic Turing machine, we have tuples like M is equals to Q, sigma, gamma, blank symbol, transition function, and initial state, and then final state. So we have Q, which is finite non-empty set of state. Gamma is the finite working alphabet, where we have input alphabet sigma, which belongs to gamma, and we have this blank symbol which belongs to the gamma after subtracting this sigma, and blank symbol at the sealed cell where never ever any input was written, and it is in the tape leftmost cell is called the blank symbol. Now the most important is the transition function. In the transition function, we see that we have a final setup in empty set of state, and we are subtracting the final state from this because the final state are not normal movement, and transition function will move um, gamma times except this final state. So, and it maps to the 2 to the power q into gamma into the right, left, right, and no movement, feed right head many times. So this is actually a set of state where we can move in non-deterministic Turing machine. And here we have also this initial state Q naught, which belongs to Q, and we have this QS and Q no, which means the final state. Now, the most important part in non-deterministic Turing machine is like you have QS. That means that the input W is accepted if only one input is accepted, and the input rejected Q, and final state is means like W may or may not be accepted. What it means, like if all the input are rejected, then we will define it with Qn, the rejected state. So the last question in this video: what is the main difference between the deterministic and non-deterministic Turing machine? The first one is that non-deterministic Turing machine allow to guess the solution for a given input, which means non-deterministic Turing machine has a couple of choice. So if in a given configuration at the p state if we give input symbol sigma, there might be some more configuration in the next states. This is not predefined, and you have branching for it. But in case of deterministic Turing machine, if you have current symbol and you put certain state on into the cell, and if you replace this symbol by another new symbol with a new state, then it's already predefined what will be the replacement state, and it is predefined. So you can say that there is a deterministic sequence step by step on deterministic Turing machine. And the main difference is shown in the transition function, where in non-deterministic Turing machine you can see that the input configuration is implies a couple of implies a set of new possible outcomes, where 2 to the power q, uh, which is multiplies with the working alphabet and the read write head many times, where the deterministic Turing machine has less outcomes in the output configuration, where you will see is it will have only q times working alphabet times read write head. So it is not a this is a single set, while in non-deterministic Turing machine has a set of states, possible states. So thank you for watching this video, and the next video will contain the information about the complexity of this Turing machine. Thank you again. See you next video.